Position vectors. Okay, so I hope there's no problems from the last worksheets. You really need to try them. I mean, we did some answers now, but whatever ones you missed, you really need to try and get them finished, okay? So we're going to look at something called position vectors. And actually, the idea is very, very simple. And you'll find that it's very similar to the last class. What we're going to introduce now, when we have points A, B, C, for example, we're going to introduce a special point called O. And this is called the, what does anybody know?
Origin?
Yeah, the origin. Or another name for it?
Vertex?
Reference point. And often, as the name suggests, you're very much concerned about vectors that go from O to other points. So for example, O to A, there's O to B, and there's O to C. So in other words, when you have a vector that starts at O, you call it a position vector. Okay? So definition. A position vector OX, let me go down a bit, is a vector from O to X, always.
Is X capital?
Yeah, capital here, but it's not so important. So in other words, a position vector is any vector that always starts at the origin. And these are actually quite useful. And with this, I'll introduce some notation. So note OX. Now, I should point out, as you probably noticed, because these are vectors, I really need to draw my arrows above them. But often, to be quick, I won't. But you should be putting arrows above these. Anyways, the vector OX, you often write that just as X. So in other words, if I don't tell you where the vector starts, it starts at O. So I'll just say that again. If you are not told where the vector starts, if I don't tell you where it starts at O. So if I just write X, it means OX. If I write A, it means OA, and so on. Do you understand?
Yes.
Okay. Another idea, which I think we mentioned the last time too, but maybe not explicitly, AB is exactly the same as minus BA.
Yeah. The opposite.
Yeah, so like if you swap A and B, you have to put a minus in front to swap it again. So for example, here's AB. Look here. Look up. Look up. Here's AB. And then this one's BA. But then if I put a minus, then it turns back to AB. So look, there's BA. And then if I put a minus, what happens? It turns back to AB. So in other words, you have this rule. AB equals minus BA. So if you put a minus in front of something, it swaps it. So a minus in front of BA swaps it and makes AB. Or if you want to write it the other way around, minus AB equals BA. If this makes more sense to you, you can write it this way. Whoops. Oh well, you get the idea. So actually, we've already done 3 rules, really. This rule, what did we do last time? What was the name of the rule? Parallelogram. And also we did the triangular rule. Okay? Or law. It doesn't matter so much. Now we're going to look at a new rule. Let's find a formula for AB. I can say, using the triangular rule, AB equals AO plus OB. Now using the rule I just showed you, I can say AO equals minus OA. But remember I said if there's an O in front, you don't need to write it, So this can be written more shortly as minus A plus B, or cleaning it up, B minus A. So this is called, this is also called triangular rule or triangular law, but it's the more common version of it. AB equals B minus A. Okay, and that actually, although looking very simple, is actually very useful. So this is an important rule. Make sure you put a box around this. Very simple, very useful, very important. Okay, do you have this? Now, let's have a look at an example. So let's say there's parallelogram, and this is my O here, and let's say this is A, this is B, and then this one here is C, and then M here, that's in the middle. Okay, and I would like to find, let's say, OM. I want to write all my vectors using just A and using just C. So let's try to find M using just A and C. So what is M short for?
Midpoint.
Yeah, but I mean, what M is from where to where? O to M. O to M, what will that equal? O to C plus C to M. We'll do it step by step, okay? OC, what way can I write that? C. CM is what?
CM.
A half
CB.
CB.
Yes.
Okay. Now, what do I need in my answer? What do I want? A and C. So this is fine. This is fine, but I don't like the B. So what I'll do is, I'll use my rule I just showed you to change this into C plus a half B minus a half C. What rule am I using there? Triangle rule.
Yeah.
The one I just showed you. This one here. I'm using that to split this. Why would I do that? Because I want to get the B out so I can change it. Is this C here fine? Yes. This one? Yes. But B here is a problem. Now if I go back to my graph, which vector is B? That's going to be here, O to B. Okay? But what does that equal? Well, O to B equals, yeah, O to A, which is just A, plus A to B, which is just C, OC, yeah. So this one here, B, is actually equal to A plus C, yeah. So I can replace that now. I can say this equals C plus a half A plus a half C minus a half C. That cancels that. So my answer is a half A plus 1 C. What do you mean no? No. Don't do that to your teacher. You can't say no. You have to ask him a question like, I don't understand this line.
I can understand that line.
Which line? The last one.
The first line.
No.
The second
What you
and
can
the
say.
third.
How did I get that one? Yeah. If you look back at the graph, B equals OA plus AB, right? Or if you want to be more clear, OB equals OA plus AB, right? But what does OA equal? That's just A. Now what does AB equal? It equals OC if you look at the graph. They're parallel. It's a parallelogram. It's badly drawn, but it's a parallelogram, okay? So AB matches up with OC. So AB can be replaced by OC. But what's OC? OC is just C. So in other words, B is just equal to A plus C. So here, you see this B here? I replaced it with A plus C. All of this here came from this one here. The B got replaced by A plus C. And then notice that this cancels this. I'll do another example. I'll do another example with this one. So please, did you draw this? Yeah, so you need to write this down. And then I'll do AM next. Yeah.
From M?
It's half CB, but CB is equal to the because it's parallel. The CB is
Oh yeah,
equal
I know. I just want to make more steps to form more rules. But yes. Don't ruin the surprise. Yes.
Is that CM? The first line? The black one?
The black one.
Yeah.
Yeah, CM. Yeah. You see, August, I want to try and use the new rule. That's why I did it that way. Oh, yeah. Here, yeah. Now, as August noticed, there are quicker ways to do these, but I'm trying to show you all the rules. So which rule did I use here? Which was helpful rule for me? Which rule did I use?
Triangle.
The triangle rule, okay? Alright, so I'm going to use the same graph, but I'm going to use AM next. So if we look at the graph now, I want to get AM. A to M. So we'll try and do this one together. So I need to go down. Do you all have the graph in front of you there?
Yes.
Okay, so let's start. AM, what could you say that equals on the graph? AB plus BM. But what could you say BM equals?
Half BC.
A half BC. Next line. Now what vectors do I want in my answer again? I think I said A and C, wasn't it?
Yes.
Yeah. So you can see I have A, I have C. What's the problem for me that I don't like here? I don't like the B. So what I'll do is I'll use the triangle rule now. So this equals B minus A plus a half C. What's next? What's next? Come on. Minus a half B. I'm using the triangle rule. AB becomes B minus A,
Yes.
Yeah, you're right.
and BC becomes C minus B. Yeah?
Yeah.
I know I'm right. It's just, do you understand? I'll go back up now. I need more space. Okay. Now, I need A and I need C, so what's the problem here? The B.
It's B.
So this equals minus A plus a half C, and then how many B's do I have? Plus a half B. How did I get a half B here? Well, I had one B minus a half a B, leaves me with half B. So this is fine. I'm happy with this. I'm happy with this. So I need to change B. But remember, what did I say B was? We got a little result here. B equals A plus C. So I'll use that. Minus A plus a half C plus a half A plus half C. Good. How many A's do I have?
Minus half.
Yeah, in total it'll be minus a half, yeah. Because this one together with this one. And then how many C's? One C. Yeah, 2 here. A half C plus a half C? 1 C. So the answer is AM equals a minus a half A plus 1 C vector. Okay, I'll give you a minute to write that down and then I'll give you the questions, but let me just stop the recording here.